Good afternoon, everybody. Thanks for joining me for the session on bringing the hammer down on malware with Device Guard. My goal is to make sure that you all leave the room knowing a new and effective method to help reduce malware attacks in your environment, and with the tools to go and start at least playing with it and prototyping right away. So this quote's been around for a little while, but from James Comey, former FBI director, there are two kinds of companies, those who have been hacked and those who don't know they've been hacked. To help eliminate the process of elimination, there's no third kind of company that hasn't been hacked at all. So this impacts all of you, impacts companies like mine, Microsoft, impacts everybody. Huge money numbers here. The 3 trillion is just too big to even think about, for me at least. The 3.5 million, though, that's a more relatable number. They're saying that each attack, on average, costs $3.5 million to do the full cleanup on. Advanced attacks can take more than the 200 days. That 200 days is the median time for someone to detect attacks in the environment. And even once you've found the attack, another 80 days to get it out of your environment. So hopefully this gives you the motivation to know we've got a serious problem. Probably the fact that you're here means you're motivated in the first place. So Device Guard consists of 3 main pieces. The first is enterprise-grade application whitelisting. The second is virtualization-based security protections. So using hardware and virtualization technologies in order to better secure your environment. And the third is hardware in UEFI BIOS lockdown. So this is making sure that the hardware you're using has the necessary security protections built in. And depending on the type of device that you're trying to protect, UEFI BIOS lockdown, so that somebody can't go and change the settings on that device, boot into something else that isn't supposed to be running on that device. So for example, if you're building an ATM or medical testing equipment, you don't want anything to run on that machine other than what you've approved to run on that machine. And so you need to lock it down even before the operating system is running. I'll be mostly talking about the first 2 things here, touch a little bit on the third one. So code integrity is the name that we give to the overall checking that the code that you're running on the system is the code that you want to be running on that system. It has integrity. It's what it's supposed to be. Just a little bit of background to help sell this some more. Whitelisting is one of the top security recommendations of multiple governments around the world, including UK, US. The quotes I have are from Australia, because I just met with government representatives a couple weeks ago, and they gave me some great material. So this is all on their website also. They have top 4 strategies that they recommend are application whitelisting, application patching, so making sure that the applications you're running are up to date, operating system patching, making sure the operating system itself is up to date, and minimizing administrative privileges. So wherever you can, running users as standard user instead of administrator. Doing those 4 things in their real-world results, they've found prevents over 85% of intrusions. So 4, I'm not going to say simple, but 4 important things you can do to cut down intrusions in your environment by 85%. And those are based on hard numbers when they look at attacks that they've seen and which ones impacted different environments and depending on who had which mitigations in place. Now, I'm willing to bet that most of you are doing 3 out of those 4. I know sometimes getting rid of admin privileges can be tricky, but most of you are probably patching your applications, patching the operating system, and minimizing administrative privileges. Application whitelisting is the one that is probably missing in most environments, and it's the one that they actually identify as their most effective strategy. So of those 4, they identify application whitelisting as the most effective strategy to mitigate against targeted cyber attacks. So when we talk about ensuring the integrity of Windows, we start, like I was mentioning before, all the way from the hardware. We call that platform secure boot. You can have, hardware fuses to ensure that you're only booting up exactly what's supposed to be on that environment. Even if people have physical access, they can't, flash your components to boot something else. And then that platform secure boot validates the UEFI environment, so that's the BIOS that runs before and loads up the operating system. UEFI secure boot verifies that the operating system, any option ROMs in your environment are trusted. And then you see the transition to the Windows OS loader, and we have kernel mode code integrity. Kernel mode code integrity we've had in Windows since Windows 7 basically ensures that any drivers running in your environment need to be signed by a trusted authority. User mode code integrity and App Locker are newer additions. App Locker has been around for a little while. User mode code integrity is new with Windows 10, and that allows you to ensure that not only things that are running in kernel need to come from a trusted place, but anything running in user mode also needs to come from a trusted place. And we have what we call Device Guard's configurable code integrity, and that covers all the drivers, all the user mode components, and in combination with App Locker, sort of gives you the full swath of everything running within Windows. You can control what's allowed in your environment, including OS components. You can ensure that you only allow up-to-date OS components, including all the drivers, boot drivers, everything into applications that you're running. But as I mentioned, whitelisting, it's their top recommendation, but it's hard. So a few of the reasons it's hard: IT code signing is not pervasive. Most people are not currently signing all their applications. Even third-party applications that you get are not necessarily all code signed. Line of business applications, you have decentralized development. So even if you put a code signing program in place, maybe it's hard to get people from all parts of the company to get their code signed, and just a lack of code signing expertise. In terms of third parties, you don't necessarily want to trust everything from an ISV, so you might trust you need to run a particular application in your environment, but that doesn't necessarily mean you want to just blindly trust all applications from whoever sells that particular application. And there's just too many LOB applications. I'm going to show you getting one simple application trusted, but if you have thousands in your environment, and you have to update those from time to time, because we mentioned earlier that application updating is also an issue, then that's a fair amount of overhead. So we've got a few tools to try to make this simpler, and then I'll talk about an even bigger simplification in a minute. Really, adopting code signing is still, I would say, the gold standard. The best thing to be sure that you're running exactly the code you expect to be running is by signing that code or having that code be signed by whoever's producing it and choosing to only trust that signed code. So you can make code signing part of your LOB app development process in terms of whenever people are submitting apps within your environment. Or we also have people who are doing it as part of their app deployment workflows. So depending on how they're deploying those apps, they can actually sign them as part of that workflow as opposed to requiring them to be signed as they come in. For legacy apps, where you have this app, you don't really have the source code, you're not rebuilding it, maybe it comes with an installer that unpacks things, we have something called the package inspector tool, and that allows you to create a catalog signature for that application that you can then use to trust it. And I'll be showing this in a minute. But basically, what a catalog is a list of hashes of all the executables in that particular application, and then you sign that catalog. And so that makes all the different executables trusted without having to sign each executable individually and potentially mess with the installation packages that you're already dealing with. So you don't have to repackage, rebuild the apps, and it's easy to deploy with SCCM. Another thing you can do is rely on the Windows Store for Business. There's two angles here. The main one, and I'm going to show you this also in a minute, is we've set up a signing service. So if you don't have your own PKI in your environment, you can use the Windows Store for Business to create a certificate for you that's unique to you and use it to then sign your applications or catalogs in your environment. The other thing about Windows Store for Business is if you're getting applications from the Windows Store for Business, then they are by definition assigned. So then you can choose to trust the signer of those applications in your environment. So that helps deal with the code signing is hard problem I was talking about earlier. Okay, first demo. There we go. Okay, so let's take, I'll show you on the VM first. Over on this VM, I have 7-zip, which we have not yet in this environment chosen to trust. Not that there's anything wrong with 7-zip, but so I'll just try to run something, and it gets blocked. So the question is, how can you get 7-zip trusted in your environment easily? So I'm going to show you the package inspector tool. What package inspector does is as you're installing an application, like I mentioned, it monitors your system and all the executable files that are part of that application, so including DLLs, scripts, etc., get added to a catalog, and then you can sign that catalog and deploy that catalog. So I've put it all in a script so you don't have to see me do typos. So I've gotten the default policy from the Windows Store for Business. So the Windows Store for Business, you can either access it through a browser and download the default policy that's created for your organization, and then from here you can also upload catalogs to sign. You can see a whole bunch of catalogs that have been signed for other demos that people have done. And then you can also download the certificate that was created for your organization. Like I said, it's a specific certificate for your organization. It's not by default trusted, so you'd need to push that certificate out in your local trust list if you're using this to do local code signing. So I've downloaded the policy using the PowerShell commandlets that we also have. So by providing PowerShell commandlets, you can sort of integrate this more into your processes instead of having to manually go up to the website and submit those. Next thing I'm going to do is some of this is just for demo. So I'm going to convert the policy to the binary format of the policy. This is just a standard built-in commandlet. The general policy is in an XML format, but when you apply the policy on the system, it needs to be in the binary format. I'm also going to sign this policy. I'm not going to fully demo signing, but what signing does, and I'll talk about it a little bit later when we're talking about the comparison with AppLocker, is it allows you to lock a policy onto a particular system so that even an administrator on that system cannot remove that policy. Now, it can also get you into trouble because if you're an administrator on a system and you want to remove that policy, it's a little bit harder. You need to essentially get into the BIOS or have a new signed policy that allows you to remove the old policy. But if for some reason you've gotten a signed policy on a machine and have lost the key or something like that, you're going to have to go in and turn off secure boot. So don't do that in your early testing. Make sure you're confident in the policies, et cetera. But once you're ready to really lock down a machine, you can use a signed policy. So I'm just showing submitting that signing job to the store portal to get it signed. Oh, I've my session is timed out, so I need to give it my password. Oh, no. All right, I'm not going to try to fix this right now. For you, it will work just fine. And then once you have the policy, you can just copy it to the correct location. You can also put the policy into this location with, obviously with something like SCCM, but you can also push it out with a group policy. What's going on here? Oh, it's not signed bin. Sorry. It's a default unsigned up bin. Right. The signing didn't work, so it's unsigned up bin, not signed up bin. Okay. So we've got the policy in place. Now, to get the policy actually enforcing Unity reboot, which I won't show right now, but I will do, since I already have one in place, is show you the package inspector. So package inspector, for most normal cases, works totally fine by itself. But to really catch the edge cases where people create like temp files that get deleted during their installation process, you also need to be running a device guard policy in audit mode. So that default policy that I got from the store starts in audit mode and would normally block the, well, the 7-zip that I'm going to show you here. So by doing that in audit mode, we get the audit logs. And when we're creating the catalog, we can look at a combination of the stuff that we've noticed laid down on the system and the audit logs to make sure that nothing gets missed. Because sometimes, like I said, if there's a temporary file that gets placed down and deleted before we have a chance to get the information on it, if you aren't also running device guard in audit mode, you'll miss that file. Okay, so so package inspector is also built in, and start C is just going to have it monitoring the C drive. And so now that it's doing that, I will go and, oh, is this the right one? No. Which is the right one? All right, so I'll just install license agreements, yes, all great. Okay. The other thing that's also smart to do is to start the application. Some applications might pull in other files or download things when you start them, so you want to make sure that you've done that also. In this case, I know that it's safe enough, so I'm going to stop the system scanning. I know that it's laid down all the files that it needs. So, okay, so we now have the file unsigned.cat. Let's see. And I'll just show it to you in Notepad. Oh no, Notepad's no good. Actually, I can show you this CDF in Notepad. So this basically just shows you that it's captured all of these files that were laid down by the 7-zip installer program and has created the hash of each of those files for the catalog. And then we can take, now my last signing job did not work. Why did it not work? Okay, I guess it was some other error last time. So I've now signed that catalog file, and if we want to deploy 7-zip, we can deploy it along with the signed catalog file. And that signed catalog file is signed with the same signer that obviously is built into the policy that you downloaded as your default policy from the store portal. Okay, so okay, so showing you on SCCM side, so you can install that catalog directly on an individual machine. This is just showing you how you could, using SCCM, deploy that catalog along with the 7-zip application. And basically what you want to do is set up a dependency. So you see, yes, the 7-zip application has a dependency on the catalog file that we just signed. I set this up ahead of time, obviously. I didn't just add this catalog file. And so when you deploy with SCCM, it'll put the catalog file down first, and then install 7-zip, and it'll all install with no complaints. I'm not going to show you the rest of that, because in a minute, there's a even simpler demo. Maybe you don't qualify that demo as simple. Okay, so I didn't time myself, but in 15 or 20 minutes, you could add trust to an application. Just give you a little more background, and then I'll talk about one more thing that we've added in Windows 10 in a preview version. So scripts, Windows script hosts will be limited. If you have unsigned scripts, then you can't invoke things like ActiveX. If you have signed scripts, then you get full functionality. And scripts can be signed the same way that we just showed by adding the script to a catalog file. Just as a sort of general heads up about whitelisting in general, you need to be aware of unenlightened third-party script hosts, et cetera, right? So if you allow something to run that then loads in and runs something else, in general, we're just looking at the first thing that you're allowing to run, right? So if you're allowing, arbitrary script host X to run and it loads in a file and that file does something, we don't necessarily have visibility into what that file is doing. Now, our local script hosts within Windows, we've enlightened to make sure that they put in these extra protections. MSIs must be signed. PowerShell runs in constrained language mode unless you have a signed script. So if you have a signed script, PowerShell script, then it can do full power. With config CI, .bat and .command scripts are not restricted, mainly because they don't have any way to directly invoke code. So if they're invoking code, then that code itself will also be checked. So if you're, say, from command trying to run something, whatever it is you're trying to run will be verified. But they don't sort of natively run code. But you can restrict .bat and .command scripts with AppLocker. So speaking of AppLocker, it's definitely a point of confusion because there is overlap between what configurable code integrity and AppLocker can do. And we're the same team, so it's not like they're competing with each other. Some people are actually using them together, so they'll create a sort of machine policy with configurable code integrity, and then use AppLocker for more specific roles. So maybe everything from Microsoft is allowed to run on your machine, as an example. But if you're in a particular role, you need only Excel, but not SQL or something. So you can lock it down more. And like I mentioned earlier, one of the things that DeviceGuard gives you is just a slightly higher security bar. We have these signed policies that will protect you from local admin. They won't be able to remove those policies. And we have that policy is measured into the TPM, so you can use it as part of device health attestation. And configurable CI just runs at a lower level in the operating system. So there's certain operations, because it's hooked right into Memory Manager, that we can't see at the AppLocker level, but we can block at the configurable code integrity level. Okay, so it all sounds great, but whitelisting is still too hard, right? That 15-minute demo didn't inspire quite enough confidence for you. So we're doing something. It's in preview right now. It'll be in the next release to try to make it even easier. And that is trusted managed installers. So the idea behind trusted managed installers is that if you have an environment where you're deploying applications using a managed installer that you trust, and you know that the everything that managed installer is installing is something that you have approved of, then is there some way that we can tie in the trust that we have within DeviceGuard and AppLocker to also trust whatever that managed installer is deploying? And that's exactly what we've done. So let's see, I'll go back to my demo client. So I already showed you this 7-zip not running. Here I'll show you, I've made a copy into program files. So even if you're just basing your rules based on path, it still won't run. And even if you're an administrator, if I come here and try to say run as administrator, it still gets blocked. So this 7-zip's not being allowed to run. If I go look in program files, you see I have this 7-zip copy, but there's no 7-zip currently. So I'm going to go to Software Center, which is part of SCCM. So SCCM has also done a little bit of work as part of this integration. Install 7-zip from here. And in this case, I'm not also deploying the catalog. So I did show you that through SCCM you could deploy a catalog along with the application. But in this case, I'm not doing any of that. I've set up the system to, by default, trust things that are installed through SCCM. So let's hope this works. OK, so 7-zip is now installed. If we go back to program files, you see 7-zip is now there. If I go in and just try to run whatever, it is not allowed to run. That's not good. Let's see here. Grabbing some notes. Oh, this is oops. Typo. Okay, so let me find the all right, I may unfortunately make you take my word for it. So in the demo prep and with partners that we've had, basically when SCCM, when config manager is laying down the application, we're monitoring it similar to what you saw with package inspector, where we were monitoring everything that was laid down by the system and creating the catalog file. We're doing kind of a similar thing on the fly for the applications being installed by CCM exec. You can see here we have this new rule collection class. What we're showing you here is actually the app locker version, and that's available with the current builds of Windows 10. New builds of Windows 10 coming shortly if you're part of the Insider program, and we'll also have it for configurable code integrity. And I do encourage you to try this as part of the Insider program. You're definitely at a stage where you can give us valuable feedback, and we do take that feedback very seriously, especially for these enterprise features, because it's not like consumer features where you have 10 million people trying the latest browser feature, right? We really need that enterprise feedback on how this is working in your environment. So all you need to do if you have an existing app locker policy is add this new managed installer rule class, and within the managed installer rule class specify CCM exec as the, I've just messed something up. Am I blind? Yeah, so you see starting here, you have the managed installer, and what we've basically done is just use the path rule. You can also use a signer rule or a file rule to specify CCM exec. But basically, we're saying that we know that CCM exec is the trusted managed installer, and whatever it lays down, we'll trust. And that can work with other trusted installers. We're definitely eager to work with other third parties, but also in some cases, if your trusted installer is like some application that you've written, there's a good chance that will function out of the box also. Yeah. So the question is, if we're doing it on the fly and we've added the catalog file into SCCM, do we have to update it in the package? So actually, that's not what's happening here. When I say we're doing the similar steps to Package Inspector in terms of monitoring the system to see what files are laid down as part of that installation, but we're not actually literally creating a catalog. We're storing that information along with those files in a kernel extended attribute. So as part of the file system information, the kernel can put down additional information, and that information is not modifiable from user mode. So we essentially say we know this was installed by that trusted application. Yeah?
Is there any interference with the GPO-imposed app locker rules?
Is there any interference with the GPO-imposed app locker rules? So in general, app locker sort of combines the rules that are coming down, but the GPO rules do take precedence. So as an example, if you had audit rules in GPO versus enforce rules locally or something, the GPO ones would apply. But in this case, if you don't have any conflicting rule, so if you have a managed installer rule here and nothing conflicting with that in the GPO, it'll also work on your local machine for local testing.
Still, something that is missing is the central overview, because you don't have individual line, you can have a table set of app locker rules.
Right, so the question is the overview question of how do you know exactly what's running, since you can have individual app locker rules. I mean, part of that is around the sort of privileges that we talked about before. So ideally you have, you don't have them as administrators so they can't create new app locker rules. And that is also, one of the distinctions like I was mentioning with the configurable CI policy. So we'll also have this in the configurable CI policy. And in that case, you can log in all the CI policies that are being applied and even attest to them using the TPM. So you can know exactly what policy is applied at any given time using configurable CI. Yeah?
What exactly are we doing? Are we allowing a process to run, or are we giving that process a type of admin access? For example, are you allowing 7-zip to run because it's already been installed? Or are you allowing the 7-zip installer to run so they can actually write the program files, which needs admin access?
Right. So the question is, what exactly are we doing? Are we just letting the 7-zip installer run so that it can then write to program files, which needs admin access? Or are we doing something a little bit different? So we are doing something a little bit different. You're right. In many cases, people will just have path rules. And that's kind of why I showed the thing not running, although nothing ran, so that didn't help me. But I showed the thing not running from the program files directory also before we created the rules. So it's not just a path rule in this case. It is allowing the specific files that were installed by CCM exec. They're essentially being marked as the files are installed, and saying,
Being given the rights, it's the files the process dropped from the scan.
right, but CCM exec is marked. So the process token for CCM exec, and that's what this rule does, is essentially marked as I'm a special kind of process. The things that I write down can be trusted to run later. I'll have a little more time for questions at the end, so I'll keep going. Let's go back to that. So managed installer, we've already talked about it, but automatically trusts software installed by your IT deployment solution, example, config manager. It's available in RS1, so that's the release we just had this summer, as a custom app locker policy with configurable CI support coming soon. So it'll be in insider builds coming soon. You can already test it out, though, with the current publicly released builds. Enables you to better balance security and manageability. So I mean, I still think the gold standard is to sign all your applications, et cetera. But to simplify the process, I think if you're already in an organization where you're deploying applications using config manager, this gives you a really quick and easy win. And I think, when they were giving that 85% number, I think you'd still achieve that. I don't think you need to get all the way to signing every application. Okay, so that was all around the sort of whitelisting aspects of Device Guard. I'm going to dive a little bit into the virtualization-based protection of code integrity, and then we'll have time for questions on any of the topics. So virtualization-based security, it's a new trust boundary within Windows. Probably to people outside Microsoft, it doesn't really mean, why does it matter if something is a trust boundary, but we take that sort of very seriously in terms of, if there's any kind of reported issue that crosses a trust boundary, that's something we'll patch immediately in the next fixes of Windows. So we've created an environment that is protected even if you get all the way to kernel, and we can store secrets or perform various OS isolated tasks there. So like I said, even if you get to kernel mode, one of the things is protection of secrets. That's Credential Guard that you've probably heard of to help protect against patch-the-hash attacks. Also, protection of guest VM secrets from the host OS. But what I'm going to talk about today is kernel mode code integrity protected by the VBS environment. So code integrity, like we talked about before, basically says when a driver is allowed to run. But even if you create CI policies, so code integrity policies that say I only trust these drivers, those drivers might have vulnerabilities. And really also turning on VBS and protecting CI with VBS will protect against a good chunk of those vulnerabilities. If you do a search in the press right now, you'll see there's actually a few stories about various vulnerable drivers. There was a game that shipped with this thing that people are calling sort of a rootkit-ish driver that people can then use to exploit your system. And they usually do that by creating new executable memory, overwriting executable memory. And having VBS protecting CI means that there's no way for them to do that. So memory pages can only be marked as executable when they've passed the CI check. So when you've passed the check for that particular code, you cannot load in other code and have that run. You cannot mark memory as both writable and executable. So if a driver tries to mark memory that way, which means that if somebody has any kind of buffer overflow, et cetera, and gets their code into memory, they can execute it. We just don't let them do that. Small print, though. I've got some fine print down there for you. Not all drivers are initially compatible. So it will depend on your environment and the age of your PCs, whether you can run this. So just quick overview, like I was saying, in sort of normal, in sort of normal kernel mode code integrity, you've got the sort of user mode and kernel, and if anything can get into kernel, it can then do whatever it wants, right? Because kernel mode code integrity itself is running in kernel, and there's no separation there. Once you're in kernel, you have full power. So kernel mode code integrity with Windows 10, we have this new security boundary, like we talked about, for the secure world, protected with the hypervisor, obviously taking advantage of CPU hardware support for virtualization. All this gets measured in. And now if malware gets even into kernel in the normal world, it has no way of compromising the secure world. And really, it doesn't have any easy way of loading in more code. Now, for full disclosure, it can do things like return-oriented programming to still cause some level of damage, and there's future mitigations for that, like kernel mode control flow guard. This is just showing there can be other trustlets that are running in the virtualization-based space. LSA isolation is what we call a credential guard internally. Okay, so one of the issues, though, like we mentioned, is that not all drivers are going to be compatible. In some cases, firmware is not compatible, or even you've got some hardware compatibility issues. We've created a tool to help you know whether your particular devices are compatible. It's called the Device Guard and Credential Guard Readiness Tool. And it'll check for things like hardware virtualization support, your driver's compatibility with VBS protected code integrity, which we call HVCI, and it can also do audit. You can also use SCCM to, to push out this tool to essentially inventory your environment to decide which machines are capable of enabling virtualization-based security. And the tool can also be used to actually turn on Device Guard and Cred Guard. So I'm going to do a quick demo on it. This demo is pretty safe. Let's hope. The demo works, but the AV equipment maybe not. Is it the VGA? There we go. Thank you. Okay, so this is just, you can just do a quick search for it. Device Guard Readiness Tool, you'll find this page. So on this machine, I want to walk you through the tool a little bit just because the output can be a little bit hard to interpret. There's a README that just shows you the different options, so you can, like I mentioned, you can even enable the features like HVCI or Credential Guard or everything. I'm going to just I'm doing the minus capable, so that's just checking whether your system is capable. I've already run it, so this is already turned on driver verifier, which is the way we validate whether the drivers are compatible. But in your environment, you might need to reboot after enabling driver verifier. And I have to run this. So what you'll see is that we've kind of color-coded the output. So if you see any red text, that implies that there's a hard block on turning on a Device Guard or Credential Guard. If you see all green text, then you're in great shape. But in many environments, you're going to see what we see here, which is some amount of yellow text. And really, most of this yellow text is about, it's probably too much of an eye chart. I can try to make it a little bit bigger. Most of this yellow text is about some more advanced security mitigations that we've been working with the industry on, so with OEMs and Intel and the BIOS vendors. So, in some of the really advanced hacking where people are, essentially compromising the firmware or compromising the SMM, or doing things like looking at memory remnants after a reboot. There's additional mitigations that you can put in place. So that's what most of a chunk of this yellow is about. So we have like secure more. More is about memory overwrite. That's about making sure your memory gets completely cleared on a reboot so that nobody can try to look at the residual what's left in memory after reboot. So that's kind of an advanced feature. Even without that, you're still getting a lot of value. NX protector and SMM mitigation, like I said, we saw some early attacks where people were attacking SMM. And if you look at the hierarchy of when you're booting a system, SMM runs even below the hypervisor, essentially. So if somebody can get into SMM, then they can compromise your virtualization-based security. So we have some mitigations that have been added to latest hardware. And then you'll see above there's a few yellow around drivers. And in most cases, the yellow for drivers is harmless. It's just they haven't been built to make sure that all the pages are either only executable or only readable. So in a lot of cases, people will execute or allocate a page that's both executable and writable, but really they're just executing it. They just, based on the APIs they used, or even the build environment, for whatever reason the pages got built that way. So in most cases it's benign. I run it on this machine with no problems. This is a 4-year-old machine. But you definitely do want to test in your environment. I would say for, if you're buying brand new machines, you should ask your OEMs for machines that are compatible and get all green. But if you're looking at deploying to some existing machines, in 99% of the time, if you're only yellow, you're fine to deploy. Although, of course, you're going to need to test in your specific environment because there may be drivers in some cases that actually are allocating writable and executable memory because they want to write on the fly, right? And if they try to do that, that can, in some cases, lead to a bug check, so crash your system. Okay, so that's the tool. Last part is just around preparing for device guard. I think I've mentioned some of this in passing, but configurable code integrity, so Windows 10 only feature, but it can work on any Windows 10 machine. So for the configurable code integrity, app locker, the whitelisting part, you can do that on any machine. There's no special hardware requirements, even though it's part of the overall device guard story. For the virtualization-based security and the hypervisor protection of code integrity, you obviously need, at minimum, virtualization support from your machine and the Microsoft Hyper-V hypervisor. And ideally, you have also those additional mitigations, especially if you're talking about purchasing new hardware. So we talk about, newer existing systems. And then we talk about sort of in terms of, where's all this stuff applicable? If you have like fixed workloads, you're building, an ATM or some specific device, then, it's very well defined exactly what's supposed to run in there. You have low churn, no standard users. Then really you can turn on everything. You can turn on the VBS protection of kernel mode code integrity. You can turn on configurable code integrity in enforcement mode, maybe even make a very strict policy. So the level of your policy can vary between saying, only these very specific binaries or trusting, anybody signed by, a trusted signer. And so if you're talking about a super lockdown environment, you might want to take a golden system, scan that system, and say only these specific binaries that I know need to run on my system. Even something else from Microsoft, I don't want somebody to bring over because that could be something they're trying to do as part of an attack. Now, a more typical fully managed desktop where it's not quite that fixed, you can still use many of those policies, but maybe you want to use the managed installer technology I just showed you to simplify the deployment. So if you've got 1,000 LOB apps, you don't want to have to scan each of those LOB apps, create catalogs for them, and deploy those catalogs. You can just use the simplification of using the managed installer. Lightly managed, if you've got admin users and they can also install unmanaged software, obviously you can use less. In some cases, you might still be able to turn on VBS and use like CredGuard and kernel mode code integrity protections, because for most users that shouldn't impact them as long as things are compatible, the hardware is compatible. But you probably cannot put configurable code integrity into enforcement mode. Maybe you can for the kernel mode drivers if you know their hardware ahead of time. But for, if they're allowed to install their own applications, and obviously you don't know those applications ahead of time, so you can't deploy a lockdown policy. And then if you're talking about BYOD devices, really there's not much you can do to those devices. Really, this is about locking down particular devices that you have control of. In terms of getting device guard ready, like I said, if you're getting new machines, it's great to ask the OEM for machines that are going to show all green on that tool. But for existing machines, many of them may be capable, and you can tell by running our readiness tool. Use the Windows Store for Business to deploy your applications. That will get them signed. But you can also use the code signing capability in there if you don't want to set up your own PKI. And that's it. There's a whole bunch of resources around the readiness tool I showed you, using config manager as a managed installer along with AppLocker, and we'll update that once we release it along with configurable code integrity also. There's last year's session. Last year's session we did show you at Ignite, we showed sort of doing a full system scan and creating the golden image and all that kind of stuff, so if you want to check that out. And there's the business portal, and there's a big, there's a deployment guide that has 100 pages worth of information on deploying. Okay, I thank you all for coming. If people have questions, there is a mic on the right, it looks like, or if you yell them out, I'll repeat them. Okay.